Angélica. My name is Jan Agri. I welcome you all to this side event of Climate Neutral Cities on the 4th day of the Swedish Innovation Days. We will be talking about buildings from buildings and other ways towards a resource-efficient construction sector. We have a program. We have an agenda with many points. I will give a brief background on the organization Resource and what we do and our research agenda. And then going from words to actions, we will be talking about a lot of practical projects. And finally, a report, a very interesting report on opportunities related to material use. If you want to have a copy of any of the presentations, you can let us know and at the info@resourcesip.se address, and we can arrange that later. This session will be recorded. And if there's any questions, unless there's any questions, Angélica, in the chat, I will go ahead.
Please do.
Okay.
Please go ahead.
Pardon me?
Yes, please go ahead.
Thank you. Resource is a strategic innovation program that supports research and innovation to develop circular resource-efficient material flows. In other words, we work with the circular economy. And we've been existing in 6 years, and we've been funded these 3 years. No, pardon me. We've been existing in 3 years, and we'll exist for 6. And we're funded by these 3 main innovation organizations in Sweden. Why do we exist? It's very much related to the extreme exponential growth of resource use. These are numbers from the Global Resource Outlook in 2019. Another way of calculating resource use is related to biocapacity. In that regard, globally, we're today using 1.7 planets, and in Sweden, where most of our activities are, we use 4.2 planets. This has severe effects when it comes to biodiversity loss, and it's very strongly related to climate impact. In other words, if we can reduce and make our resource use more efficient, we can directly impact the climate. And the number 70 is from the recent Global Circularity Gap report. We've been working to create a research agenda, or rather an innovation agenda. And it was published in Swedish and English in the fall. It provides input for what we see are the most important targets and what needs to be done. A summary of the 7 most important priorities is seen here now on the screen. It goes all the way from making this a national priority to improving policy and legislation, both on a national and on a super regional level. Of course, if you want to change something and you want to be able to follow up, you need to have metrics. And we work very much with creating knowledge, practical knowledge, and sharing that as reflected in point number 5. And in order to this, for us to be able to support a sustainable development with our focus on the resource use, this needs to be integrated, just as the work to improve the climate situation needs to be integrated in everything. And as being part of the innovation system in Sweden, we are very much focusing on the national competitiveness, you could put it. And that's related to the fact that we're an exporting country where the businesses need to be able to integrate this and come out as more sustainable businesses. This is not the only thing we work with, of course. There seems to be some delay. We are right now working on a circularity gap report for our country. There's been a number of those made before, most recently for Norway. We are now in the final preparation phase, so we will have it out in April. It will provide guidance for us in the country to understand where are the big questions to address. But more importantly, and as part of why we are here today, as a strategic innovation program, we work very hard to bring different organizations together. And it's 1,000 different applications from organizations that we received over the first 3 years. 50% are from private companies. And in practice, we worked with more than 200 projects. Some are still ongoing, of course, and we will have a call out in March, ending in March, where we hope to get a lot more projects. And many of these projects say that they are developing new solutions. And I'm very happy that we now have a chance to talk to, or listen to rather, some of the projects that we've been involved with. No intention to steal the thunder from the people that actually do the work, but we are very happy to support. May I, let me see, let me go back to the agenda. To remind you, that was the short introduction. Now we will listen to Nadine Aschenbach from Codesign. I hand over to you, Nadine.
Thank you, Jan. I hope you can all hear me now.
Yes.
Nice. Hello and welcome, everyone. I would like to begin with this quote from Jane Jacobs. Old ideas can sometimes use new buildings, but new ideas must use old buildings. We lean on these words a lot as they emphasize the power of renewal that is embedded in our cities and buildings. I am here today to give you a short introduction to the innovation project From Building to Building, which is all about the reuse of heavy load-bearing elements like beams, columns, stairs, and ceilings from existing buildings in new construction. My name is Nadine Aschenbach, and together with my colleague Jelena Mijanovic, I am project managing this innovation project, and we are both architects in Stockholm. You have an overview of the project facts. We are using a method that we call collaborative practice-based innovation. I will tell you a little bit more about that later. The coordinator is Architectural Practice Codesign, and the project is now funded in collaboration between the private sector, the project partners, and the public sector. Like we now get funding from Sweden Innovation Agency, Vinnova, but we have earlier received funding through the Swedish Energy Agency through Resource. These are all our collaborating partners. We're very happy to represent all actors of the value chain of the construction project. And we are also very happy to have a very broad skill set, everything from special material specialists for testing and to design, management, construction, everything. And you can see in the center the big Swedish property developers and owners. Here we have the contractors, technical consultants. Ramboll is an international company. And we have with us also Research Institute Sweden and Thesis Group, which are a specialist in circular economy, and also the public sector with Stockholm City. The Sustainable Development Goals and Agenda 2030 are, of course, essential to us. And for us, it's very important to understand that all goals form a system and that everything is embedded into the biosphere, the living world. Our strongest driver is goal number 12, responsible consumption and production, but we also contribute to secure, safe and healthy work environments and to sustainable cities and communities. Here you see more specifically the vision and the three main goals for our project From Building to Building. Our vision is a transition of the construction industry towards a circular economy. And our main goals are cross-disciplinary, professional, systemized process and business model, a shift of paradigms with a new view on demolition properties as a resource with continuous values, the protection of the living world by reducing our impact, less waste, less emissions, less use of virgin materials. And this essentially means that we need to see existing buildings as resource equal to natural resources. And to achieve this, we need to work together across disciplines and industries. Our project is organized in work packages. They're based on the most challenging needed thresholds and solutions that are needed that we have found in the project course. And the packages are interlinked and show how we work with system innovation. We really have to drive change in all these critical areas at the same time. But we can also say that package 7 really is the heart of the project. Hence, we call our method collaborative practice-based innovation. We have 4 pilots where we can test and verify all the solutions right in practice. And we believe that this gives our results legitimacy that we need. And now there's a teaser how our work in progress is progressing at the moment. But it's really going to be just a teaser, so please get back to us with questions. These are the 4 active pilot projects, and what they have in common is that they are objects to be demolished, and they're all offices from the 1970s and 80s. And in this current situation, the developer owns the property for deconstruction, and the developer also have the ambition to reuse the material in their own new build projects. And to the right of the images, you see the developers and contractors who are really being brave and willing to try. We have started with looking for demolition to understand the potential of the existing buildings and whether the materials in the building parts are any good for another life cycle and another life cycle. And we have started with developing a method. Well, we are testing different aspects of the reuse project, and the 4 projects that you've seen before, they are in Onsala municipality. I'm going to go a quick step back to tell you that they also have in common that they're all concrete structure. As the Onsala municipality projects are precast concrete, and Kvarteret Hugin in Uppsala is in situ cast with its own challenges. And we're testing different aspects of the reuse in the different projects. We have started with develop a method to make sure that the product quality is good for a reuse in preparation of a new project. To the left, you see the main steps to identify the reusability of an existing building and its parts. And with the 3 main steps of an inventory mapping based on documentation, then visual assessment on site, and non-destructive testing, since we want to keep what we want to use. And then we need to test samples more in a destructive way to be sure. And that's at least the assumption today. And all of this to actually make sure that the materials and products are never classified as waste, and that they stay products within their original qualities on the market. Just a quick example of the quality of drawings that we are handling now. They are from the 80s and 70s at the moment. But nevertheless, please keep all your own old archives to make this work possible. And then we're using them to count on word volumes, but also as well as the volumes weight, we look at the size and numbers of modules that we have to work with in the existing buildings. Here's an example of the visual assessment and non-destructive testing methods. We're using scanners on site to see the position of the reinforcements in the concrete, and also whether there are possible cracks in the structure, and also the resistance of the materials through hammering, Schmidt hammer. We also take drill samples. We have tested this now several times in our Solna pilots, where the samples are taken to the lab to see structural strengths and also chemical compounds and carbonization, layering, and so on. We are very happy that one of our pilots has already gone into the next phase, and they have taken bigger samples to be tested in the RISE laboratory in Borås. And they have even proceeded with the deconstruction, and that is the project of Fabege and Sengum. And this is what we call system innovations paradise. There has really not been any, how to say, it has been a very smooth and fast, a relatively fast process. And in this case, as you can see, the precast ceiling slabs have been harvested to be mounted into a new building on the same site. We are now assessing also how the construction method is influencing the overall time schedule, costs, and also how competences are used. So, for instance, has the contractor for mounting the precast ceiling slabs also been involved in the deconstruction to make sure that they're handled correctly? There has been a big advantage that the old and the new are really close together, just a few meters apart, the sites, and there hasn't been any major transport except for the crane maybe. And also one advantage was that this new building is an on-site office for the contractor, and it's been a temporary planning permission for 10 to 15 years. But we can also say that the structure that has been used, the concrete, is a much longer lifespan, maybe a couple of 100 years. Yes, I also quickly tell you how this feeds into our circular economy model for those projects. We, of course, can measure hard facts for future planning and budgeting of reuse projects with reused materials. We get out numbers about of volumes that we have, of course, and monetary costs, how both the management and the logistics are also influencing the budget. And we are mapping the process, including where to find new competences in the work phase, the new work phases that have to be calculated for, and decision-making moments, permit processes, planning permission, for instance, is one of those. We're also looking into the indicators that should be measured to understand our environmental impact. This diagram shows our approach with the biodiversity in the center, and we're leaning also on the indicators from the life cycle analysis. And we also want to have socioeconomic costs in the calculation, which we think it gives value to the reused material to be to also understand the value of the material. And we see this cost as the cost that is avoided by the society to carry because reuse reduces our impact on the environment. Instead, that the already existing materials impact a lot less than if we have to take out virgin materials. So we're trying to set a number on that, so throw it in the equation. We think that's important. So I know it's just been a teaser. I hope you enjoy the rest of the presentations, and if there are any questions, don't hesitate to contact us, and we will also happily put you in contact with our partners. Thank you for today.
Thank you. I think we will hopefully have Linda Cusomano of NCC take over it directly. So, Linda, very well. Please go ahead.
Yes, thank you, Jan. Hi, everyone, and thank you for giving me this opportunity to present the project Onsala Space Observatory for you. My name is Linda Cusomano, and I'm working at NCC Building Sweden, which is one of Sweden's largest contractor companies. I'm splitting my time between the division Research and Innovations and Technology and Sustainability, where I work as a structural engineer and design manager. I will start with giving you a short background about the Space Center. It's really placed in a very beautiful position next to the sea in Råö, Onsala, that is on the west coast of Sweden. It was founded in 1949 by Professor Olof Rydbeck. And there they have 5 large radio telescopes for astronomy and geodesy. And their focus areas are astronomical observations of sea levels, Earth crust, and atmosphere. So all highly interesting areas given today's climate crisis. And on this site, they have a visitor center that is focusing on children wanting to explore space technology and astronomy. And about the project, we are building a new visitor center and exposition hall because the existing one is small and outdated, and it's not fulfilling its purpose any longer. And the project consists of demolishment and renovation of an old building from the 50s, and it's combined with production of a new building. And the layout of the new building you can see there to the right. The client is Chalmers University of Technology, and the developer Chalmers Properties. The contractor, who I belong to, is NCC Building Sweden, and architects have been White Architects. So what's so special with this project? Well, we have a requirement saying that minimum 85% of all construction material used in the project shall be reused material. And this is not only the structural elements, it's also all interior, it's also ventilation and electrical equipment. So it's a great challenge and possibility, of course. We have had some challenges in this project, as you might guess. And I will start with the first most striking one, and that is that we cannot use any internet connection or Wi-Fi, and we cannot use our cell phones because this is a radio observatory, and of course that kind of activity gets disturbed by usage of phones. Another great challenge have been to find the right material in right time, because we do not want to store the material we found too long, but we also need to make sure that we have it there on site when we actually need it. So this has been a great challenge. Another challenge have been how to make design drawings allowing for the right flexibility. We have an idea of how we want to build, but how we finally build it depends on which materials and products we will find, and we need to allow this flexibility in the drawings. Another challenge has been to specify minimum requirements and also the quality proofing of reused materials. And as with all reusage projects, time and cost efficiency have been a challenge. We see that working with reused elements and materials costs a lot of time. And then finally, we have the warranty issue, because we are using second-hand materials and products, but we still need to provide a warranty to our client. And how do we do that in a way that we all feel comfortable with? But we've also had a lot of solutions in this project. The first one, back to basic, paper drawings and a fixed phone in a building nearby. That's how we communicate in this project. And I must say it works amazingly well. We have also had a reusage focus group within the project that have been there to facilitate everything regarding the reusers, like the process, software used, and actually searching for materials. We have also a logistics center for storing material. This was identified as a necessity very early in the project, and yeah, it has been extremely useful. So all materials we find, we temporarily store there for then transporting to the site. We have developed systems and softwares for continuously monitoring our needs versus our findings to see the progress in the project. And we are also calculating the CO2 equivalents, the reduction compared to what it would have cost us in terms of CO2s if we have built everything out of new materials. And last but really not least, it's the networking. All persons involved, all the designers and all the subcontractors have really used all their contacts to try to find reused materials, and it has been a great help for the project. We have also two innovation projects connected to this. One is Resource, There is a practical demonstration of reusage within the construction industry. And the other one is a cooperation between Resource and SBUF. And SBUF is the Swedish construction industries organization for research and development. And that project regards testing and decontamination method of reusage of timber. So there we have tried ways to fast identify the mold growth to make sure that we are not building in any timber with mold growth on. So finally, I want to end with some examples of reusage. What have we reused? First of all, timber and steel elements. Steel elements, I must say, have been a great challenge, not because it's not available, it is, but the present demolishment methods in general destroys the elements so much, so it's inappropriate to use them in this kind of reusage purposes. We have used piling waste as a new foundation. We needed to dock the new building to the existing building, and the existing building have a quite high floor height due to the overflow risk. So we needed to reach that level, and we were not allowed to use new fossil materials. So we actually, from another construction site, took piling waste and we placed them horizontally, like building with Lego bricks, and attached them to the bedrock. And you see on the small picture to the left here, that how we place the building on top of it later. And some other examples, toilet groups. We found a demolishment project in Stockholm where they were going to waste toilet groups. So we took them and transported them and mounted them in one of the existing buildings. Various ventilation devices and air ducts we have used. Doors, windows, kitchen equipments, a lot of them. And of course, all doors and windows from the building we are demolishing, we are reusing in the new one. And then also a lot of insulation and various boards. So that was a very brief introduction to this project. And if you have any questions about this project and how we handle the reusage, don't hesitate to contact me. You see my email address there in front. So thank you a lot for your attention.
Thank you, Linda. Thank you very much. Now I will hand over to Angélica Karlsson at the city of Gothenburg.
Thank you, Jan. Yes, my name is Angélica Karlsson, and I work as a building engineer at the municipality of Gothenburg City. And I'm at the management department, which builds schools and preschools and retirement homes and homes for people in need of special assistance. And today I'm going to talk about the Hoppet Innovation Program. And Hoppet, it means hope. In this case, a hope for a better future, or it also means a leap. And in this case, a technical leap. And the innovation program aim is to reach for building fossil-free and climate neutral. In 2017, we got the assignment to build a fossil-free and climate neutral preschool, which now is ready. And this pilot is the first step towards total climate neutrality, and the goal is supposed to be reached in 2030. To reach the goal, we have found 5 strategies, and the first strategy is to minimize material, and strategy number 2 is to use reused materials and circular products, and 3, to use bio-based materials, and 4, to choose material with the help of life cycle assessment, and 5, to have a fossil-free construction site. If we take a closer look at the different strategies, it's only the strategy of minimization that can reach the goal of climate neutrality, like no material, no climate impacts. The strategy of using reused materials is today the only way to come close to climate neutrality, and that if we put the climate impact that a product has in the manufacturing phase in the first loop of use. If you then reuse a product in a new building, you only need to take the redesign and logistics in consideration. In the first pilot within the Hoppet, we have chosen to focus on new material for the main part of the construction. And the main material of the framework is wood, and the inner walls are built of cross-laminated timber. And the circularity in this material is the characteristic of solid wooden blocks that are easy to assemble and then dismantle and build with again at another place. And this goes as well for the foundation, which is made of a high amount of recycled glass, pressed together to a foam glass block framed with steel. This material lasts for hundreds of years and are also easy to dismantle and use in another project in the future. When we come down to the use of reused material, we have had two different approaches. The first approach is that we did an investigation of what products and materials we knew we could use. We have an own stock with mainly materials for the outdoor environment. So the first step was to make an inventory of the material available. And after making a list of the available material, the landscape architect could do its drawings and description from that. This way of approach is very effective because you have the resourcefulness over the whole process. What you do in the design phase is what you get. The other approach was to ask all the projectors to make a design with standard dimensions and to note what's suitable for reuse. This way of approach opens up for a large amount of recycled materials, but it's also risky because you can end up with no reused materials at all. During the start of the project, we set up a goal that it should be at least one reused product per discipline. So what became the result from that goal? We have 3 ancillary buildings where all the foundations come from rest material of concrete piles. And one of the buildings is all made of reused brick stones. There is a company in the region, they take care of old stones named Bruksspecialisten, who remeasures the load-bearing qualities and other properties and resell the stones again. The stones in this building comes from a health center that needed to be demolished. In another demolishing project, we have taken care of the brick stones from that school and taken them to Bruksspecialisten. I think to stimulate a market for reused materials, you need both to ask for reused materials, but you also need to make materials available. This example is also what we see as the desirable scenario. You as a builder should make materials available, and then there is other companies that take care of the product, manages the redesign and the resell. So you as a builder can order reused materials as you order new materials. Where we are now, you need to put a lot of time to find and match product, which is fine in a pilot and in the phase where we still form a market. But if it's going to be praxis, which it has to be, to save the climate, we need a huge number of companies that are dealing with reused material. Materials that we had in our stock that now you can find at the first Hoppet project is, for example, ground plates, play equipment, and benches. And in the interior, you can also find reused cable ladders and basins and acoustic panels. And a lot of the reused materials come from demolishing projects within the city. And also in the interior, you can find reused furnitures as tables and chairs. And this comes from other schools and preschools within the city. And during the way, we have found and developed tools that make your work with reused material easier. For example, we are one of the project partners in the collaboration platform CC Build, where you can share and take part of other experiences and good examples of how to handle challenges of reused materials. CC Build also offers a digital application for inventory, and you can both have your own digital stock and put up your product as at the external market. When we started the first Hoppet project, we haven't digitalized our stock, but now we are under digitalization, which will make the next project much easier. We have also made an Excel tool, which should help both for inventory and to choose what materials you should reuse. The matrix takes in considerations the materials' impact of the climate, how easy it is to assemble and dismantle, and how much money there is to save when you reuse compared to new materials. But if it's going to be a real change, it has to be in a lot of projects. So our next step within the Hoppet program is to implement the solutions from the first pilot. And all buildings we are planning from this year will have at least a reduction of CO2 of 50%. And we will try to have requirements that are not limited to any specific technique. But we have also pointed out that the base are supposed to be wooden construction. And we are trying to do 5 new projects with foam glass foundation. And we will have 3 projects with fossil-free construction site and 3 bigger pilots that are focusing on reuse, and also 10 smaller projects focusing on the reuse. So from now on, we are going to build all our projects more fossil-free and climate neutral. And in one of the projects, we will take the use of reused materials even further. This project is an old school that needs to be demolished before building a new preschool. And we will save the foundation and make the design from the old foundation. And the use of more reused material will be much higher than in the first Hoppet project. And if you want to know more about the Hoppet Innovation Program, you are welcome to visit our website. And thank you.
Thank you. And now I would like to give the word to Marianne Hedberg of the Swedish Construction Federation.
Yes, I just need to do like this, right? My name is Marianne Hedberg. I work with environment issues at the Swedish Construction Federation. And we are a federation for construction companies, not the house owners or the consultants, but but we actually do the building. And we have about 3,800 member companies and employ a lot of people in this sector. So what we are doing, this roadmap 2045, we build a sustainable future. This is a roadmap for a fossil-free and competitive construction sector. And this roadmap was compiled as one of many sectorial roadmaps under the government initiative Fossil-Free Sweden. Skanska was the project leader for presenting this roadmap, and it was presented to the government in 2018. And after that, the Swedish Construction Federation accepted the leadership for implementing this roadmap. And the overall goal is to unite the value chain of construction to achieve a common goal. And the goals are climate neutrality by 2045, and by 2030 we should halve the emissions. So during 2020 to this year, all the signing bodies should investigate their impact and set up an environment policy and a work program to reduce their impact. And what we see is that with current technology, we can halve the emissions by 2030. But to achieve climate neutrality, there is a need for innovations. And today we see that materials produced and used for construction are the main sources of climate emissions, since the energy efficiency of the buildings have been, it's much greater now than it used to be. But since most buildings already exist, we also see that it's not enough to adapt a new build, but we also need to see deep renovations of existing buildings to achieve a climate neutrality. What we did was gather all the value chain of construction. Today, the roadmap has been signed by over 160 companies and federations, municipalities, and so on. And so this broad representation of the sector is very important to achieve a well-founded discussion along this value chain and to establish a common awareness of where we are, a common language for demands and follow-up, and thus awareness of what we can do together. And when the Swedish Construction Federation took lead of implementation of this roadmap, we made two distinctions. First, this is not a project. It's an ongoing change for the whole sector. And second, the time for solving one problem at a time is long since over, and we need to address sustainability as a whole. And it's definitely much more difficult, but we need to keep the whole picture in mind in order to find the best long-term solutions. And what we did was start gathering all the signing bodies to a meeting to prioritize and get started with the work, because there are a lot of issues presented in the roadmap, and we cannot do everything at the same time. And we invited all the 60 original signing bodies, and we thought maybe there will be 15, maybe 20 if we're lucky. When the number exceeded 60, we had to go and book a new area to keep the meeting in, because the interest was very big and it has grown steadily since then. And we have, after prioritizing, we have had several meetings with all the co-signers and workshops with focus area specific with green finance, early stages and groundworks, to name a few. And we also started a number of specific projects. And for now, we are focusing on a couple of projects. The ones with 2 asterisks are projects that are completed, and there's a report available. And since everyone was supposed to map their impact on sustainability, we started by presenting a material on how to follow up a company's impact. And this is done with a focus on the small and medium-sized companies, because the really big companies, they have indoor competence to do this on their own. Sustainable procurement is really important, and we ended up with a model for defining the various responsibilities within this value chain. Green finance is not a project really, but an ongoing discussion, and we have the EU taxonomy, for example, to relate to. And the other ones with one asterisk are ongoing projects. And it's important to spread this initiative nationwide, but it is also very important to start discussion locally. And the big companies and the big cities, they tend to go forward on their own, but the discussion needs to be much broader than this. And we win effectivity in this discussion. And we also need to incorporate the discussion about sound competition, because we have seen for too long that companies that accept a very a project offering at a very low cost seldom have the intention of actually fulfilling the sustainability demands. So this is very important. And the vision, of course, is that the construction sector creates lasting value in a changing world. We have to admit everything is changing, and we want to contribute to a sustainable society. So if you want to join the roadmap, or if you want to have more information about any of the project, please get in touch either via resource, or you have my email address there. So thank you for listening.
Thank you, Marianne. It's a very, very exciting example of a strategic project. And talking about strategy, I'm very happy to hand over to Robert, who will present what his company is doing to support strategic projects all over Europe with quantifications regarding resource flow. Robert, are you there? Yes, I see you. Welcome.
Yes,
Go
I'm
ahead.
here. Thank you very much. Then I'll start sharing my screen. No, so I'll give, as we only have 4 minutes left, I'll just focus on the key messages. But then to start with, we have done basically 4 large reports in collaboration with Resource. I will focus on the bottom left hand here on preserving value in industrial materials for the EU. Where, of course, the construction sector is one of the biggest materials users across the economy. But then we have also done several reports together with Resource on also how the use of materials relates to our climate targets, and how we should tackle the low carbon transition that we have in front of us in the EU. So all of these reports are also available on our webpage, materialeconomics.com/publications. But if we start with just the summary, so basically when we look at the overall European economy and the main industrial materials, so aluminium, steel, plastics, and this is in all use segments on top of buildings, so it's also for cars, other types of products and so on. It's about 130 to 140 billion euro of materials value that basically reaches end of life in their products every year. And we as a continent, and also in Sweden, we believe we are very circular, but we took a value perspective on circularity, and basically after only one use cycle, only about 40% of this original value is actually kept. And that is mainly due to quality losses and volume losses. And this is, of course, a huge problem for circularity to scale. And to address this, of course, there needs to be a lot of focus on how to work with cleaning up flows of materials, reducing contamination, creating closed loops, but then also connecting it, of course, to the whole climate topic, as recycled materials has a very much lower CO2 footprint. And when we look at this from a kind of overall systems perspective, we are today at a supply of end-of-life materials that's about 64% of our total production, or basically the total need in the EU. And this is set to increase to more than 80%, almost 90% by 2050, as we are kind of saturating the use of materials. So basically the story is that if we treat our materials in a really good way, we could almost live entirely off our own scrap over time in the EU. And this is, of course, a super important conclusion, because this is the foundation of circularity. And then it's, of course, how to do it is, of course, the tricky part, but the potential is very, very large. And when we look at it from specifically the value perspective, see here the breakdown of the point that I just made in the beginning, that starting off with about 140 billion euro of materials value, we have them volume losses that basically takes away that we end up only with about 76 billion euro materials that's actually treated in a way to do actual materials recycling. But then also in the materials recycling process, we lose significant value due to quality losses that basically are realized as price losses, because the recycled material is often worth or valued much lower than the primary material due to quality issues. So this is, of course, a huge problem, and it's a huge opportunity as well to solve, to generate, of course, business opportunities, but also very large societal opportunities to improve our materials flows and then save money, and at the same time reduce the need of primary materials, and thereby also reducing, of course, the environmental and societal impact of primary materials extraction. This, of course, becomes even more important when looking at also materials outside of these, for example, with a large scale up now with electrification and batteries and rare earth metals and so on. So this type of perspective becomes, of course, very important across all of our materials. But as I said in the beginning, this report and several other of the reports that we have done together with Resource is available on our website. We can also share this presentation to the audience now. Yeah, unfortunately, we don't have more time now, but I hope at least the main messages have come across to all of you.
Thank you very much, Robert. And I know you need to go, so thank you. We have already shared one link in the chat, and your website is easy to find everything there. It's really a very, very important report. So I encourage you that have an interest or use for this to look them up. Thank you.
Yep, thank you.
Before we finish off, this is what we've seen today. Again, we would be happy to discuss what we do and also to put you in contact with all the different presenters today. And we hope you enjoyed it. If you have any questions or comments, please let us know via email. You see the address in blue at the bottom of the page. Thank you very much, everybody. Have a great day.